All right, in this lesson, we're going to be looking at the triangle congruence theorems. There are essentially 4 tests that we can use to determine if 2 triangles are congruent. First is side, side, side. If all 3 sides of one triangle are congruent to all 3 sides of another triangle, then the 2 triangles are congruent. Next is angle, side, angle. If 2 angles of one triangle are congruent to 2 angles of another triangle, and their included sides are congruent, then the 2 triangles are congruent. Now, included means between. So the included side for those 2 marked angles would be the side between those 2 marked angles. Side, angle, side is the next test. If 2 sides of one triangle are congruent to 2 sides of another triangle, and their included angles are congruent, then the 2 triangles are congruent. Just like included side means the side between the 2 marked angles, included angle is the angle that is between the 2 marked sides. And then the last test is angle, angle, side. If 2 angles of one triangle are congruent to 2 angles of another triangle, and the non-included sides are congruent, then the 2 triangles are congruent. All right, so in essence, if you can determine that 2 angles of one triangle are congruent to 2 angles of another triangle, and you have one side that's congruent, it doesn't matter whether it's included or not included, then you can determine that the 2 triangles are congruent by either angle, angle, side, or angle, side, angle. All right, so we want to determine if these 2 triangles are congruent. First thing we want to do is mark AP, because by the reflexive property, AP of the left triangle is congruent to AP of the right triangle. And then now we have 2 angles marked as congruent and the included side. So we would conclude, yes, we can conclude that these 2 triangles are congruent by angle, side, angle. The congruent statement, you always start with the triangle that's on the left, or if they're above and below each other, use a triangle at the top as the left part of the congruent statement. And then you would have triangle GAP is congruent to triangle S corresponds to G, A corresponds to A, and P corresponds to P. In this example, we can go ahead and mark that BD is congruent to BD. That's a reflexive property. And we're also told that BD bisects angle ABC, so we can mark angle ABD and angle CBD congruent. And then now we can conclude, yes, that these 2 triangles are congruent. One of the tests that we could use is angle, side, angle. We could also use side, angle, side. We can also use angle, angle, side. And the congruence statement. Try to write the left side of your congruence statement in alphabetical order. So A, then B, then D corresponds to, A corresponds to C, B corresponds to B, and D corresponds to D. All right, we want to start by marking WY congruent, since reflexive property tells us the WY is congruent to WY. And we only have one angle and a side marked in both triangles, so there's not enough information to conclude that the triangles are congruent. Here we want to start by marking DF congruent to DF, again, reflexive property. And we can mark these alternate interior angles congruent, since we know that DE is parallel to GF. Since DE is parallel to GF, alternate interior angles are congruent. And now we have 2 angles and a non-included side, so that would be angle, angle, side. All right, start with the triangle on the left. So in alphabetical order, D, G, F. D corresponds to F, G corresponds to E, and F corresponds to D. And in this example, all three sides of the triangle on the left are congruent to all three sides of the triangle on the right. So they are congruent by side, side, side. And again, start with the triangle on the left. Put the letters in alphabetical order. So X, Y, Z. X is between 14 and 21, just like L is. Y is between 21 and 10, just like N. And Z is between 14 and 10, just like M. And here we've got two congruent triangles. And we know that they're congruent because all three sides of the triangle on the left are congruent to all three sides of the triangle on the right. And if you write the left side of that congruence statement, you have ABT on the left. And then A corresponds to either O or D. B corresponds to O or D. And T corresponds to G. All right, in this figure, in these next couple examples, we want to determine what the included angle is. So again, included angle is going to be the angle between the two marked sides. That would be angle F. In this example, to determine what the included angle is, the included angle is going to be the letter that is common to both of those sides. So an XZ and YX, X is common to both of those. So that lets us know that angle X is the included angle. Here we only need to look at the two congruent sides, DE and FD. Both of those two sides have a D in them, so we know that D is the included angle. Here again, we want to determine if the two triangles are congruent. First thing we want to do is mark angle ACB and angle ECD congruent, since they're vertical angles. And now we can conclude that the two triangles are congruent by side angle side. And start with the triangle above, triangle ABC. And A corresponds to E, B corresponds to D, C corresponds to C. Here we're told that this is an isosceles triangle and JK and KL are the two legs, so those are the two congruent sides. M is the midpoint of the base, so JM and ML are also congruent. And we know MK is congruent to MK by the reflexive property. So we can conclude that these two triangles are congruent by side, side, side. The congruent statement written in alphabetical order on the left side, JKM, J corresponds to L, K corresponds to K, and M corresponds to M. Here we've got, in the two triangles, we've got one angle marked congruent and one side, which is not enough. We back up. The side that they share, it's congruent to both of the triangles by the reflexive property. So we can now conclude that the two triangles are congruent by side angle side. Triangle on the left, ABC, A corresponds to D, B corresponds to B, and C corresponds to C. Here we've got two sides and the non-included angle in the left triangle. In the right triangle, we've got the triangle on the right. We've got two congruent sides, and then in that one, it is the included angle. So we have the included angle on the right side, non-included angle on the left side, so not enough information. First thing we should mark in this example are the two vertical angles in the middle. And then now we can conclude that these two triangles are congruent by angle, angle, side. Start by writing the congruent statement with the letters in alphabetical order on the left side, and then N corresponds to L, J corresponds to M, K corresponds to K. And then here we can mark the middle side congruent by the reflexive property, and then conclude that the two triangles are congruent by angle, side, angle. And to complete the congruence statement, ABD, A corresponds to C, B corresponds to D, and D corresponds to B.